Once more, invite star darlings. Have you ever imagined witnessing a cosmic event so grand that it casts shadows across Earth? This rare occurrence might be closer than we think. In the Orion constellation, the star Betelgeuse is exhibiting unusual behavior, hinting at an impending cosmic event that could illuminate our skies like never before. But when exactly will Betelgeuse explode, and what will this celestial spectacle look like? According to scientists, this explosion could unveil profound cosmic mysteries. Join us as we explore the secrets surrounding Betelgeuse and the potential impacts this event could have on Earth, as well as the entire solar system. Located approximately 650 light-years away in the Orion constellation, Betelgeuse is no ordinary star. It is a red supergiant, one of the most luminous stars we know, shining over 100,000 times brighter than our Sun. But why is this massive star so significant to us? Beyond its brilliance, Betelgeuse holds deep cultural significance. The name Betelgeuse derives from the Arabic phrase Yad al-Jawza, meaning the hand of Orion. This star has been observed and documented by ancient civilizations for centuries, guiding travelers and captivating astronomers with its distinct red hue that sets it apart from other stars in the constellation. Imagine a single star so massive that it could dwarf our entire solar system. To put it into perspective, if Betelgeuse were to replace our Sun, its outer edges would extend all the way to Jupiter. How does such a star achieve these epic proportions? At around 10 million years old, Betelgeuse is much younger than our 5-billion-year-old Sunday. However, its immense size causes it to burn fuel at a much faster rate, resulting in a much shorter lifespan compared to other stars. This stellar giant, with a volume large enough to contain over 1 billion suns, is nearing the end of its life cycle. When stars of this magnitude reach their twilight years, they don't simply fade away. They go out as a supernova, a catastrophic explosion of unimaginable energy and brilliance. Such an explosion has the potential to outshine entire galaxies, casting shadows of light across vast cosmic distances. The last time Earth witnessed such a nearby cosmic explosion was in 1604, before the advent of modern telescopes. The Kepler supernova, visible for over 18 months, was the most recent supernova observed in the Milky Way. It was so bright that it rivaled other stars in the night sky and remained visible even during daylight for weeks. Supernovae, though rare for observers on Earth, reveal hidden truths about the violent ends of massive stars. Historical records from civilizations, including Chinese and European astronomers, documented the appearance of new stars, providing insights into these celestial deaths. The remnants of these explosions, seen today as expanding clouds of debris, continue to offer valuable data about the dramatic finales of supergiant stars. Imagine an event so powerful that it rivals the brightness of the full moon, casting shadows on Earth at night and possibly being visible during the day. The radiation emitted by such an event would be so intense that it could ionize our atmosphere, disrupt satellite communications, and even influence weather patterns. Betelgeuse, with its erratic dimming patterns, appears to be preparing for such a dramatic display. Could we be on the brink of witnessing one of the most extraordinary events in the universe? Between October 2019 and mid-2020, Betelgeuse underwent a remarkable transformation that captured the attention of astronomers and stargazers alike. Known as the Great Dimming, this change in the star's brightness, which had been relatively steady for decades, began to drastically decrease. This sudden dimming was so noticeable that even casual observers could see the difference when comparing Betelgeuse to other stars in the Orion constellation. This suggests that we might not be centuries away from witnessing Betelgeuse's supernova. It could happen within the next few decades, or perhaps even sooner. By April 2020, astronomical observations showed that Betelgeuse had returned to its normal brightness levels, convincing many that the dimming period had ended. In a stunning twist, over the subsequent months, Betelgeuse's luminosity surged by an unexpected 50%. While fluctuations in brightness are common for variable stars, such dramatic changes are highly unusual for a star like Betelgeuse, which typically exhibits consistent patterns of luminosity. This sudden increase in brightness thrust Betelgeuse back into the spotlight, raising questions about what caused this unexpected change. Why did this once predictable star suddenly experience such dramatic fluctuations? Stars are not just fixed points of light in the night sky. They are dynamic, evolving entities with life cycles, behaviors, and mysteries of their own. Typically, stars' changes in brightness occur in predictable patterns, much like Earth seasons. Betelgeuse had maintained a relatively consistent 400-day luminosity cycle throughout much of its existence. However, with the Great Dimming, it seemed to defy this established pattern, challenging our understanding of stellar phenomena. Now, you might be wondering, are we on the verge of a cosmic revelation? While the exact reasons for Betelgeuse's unusual behavior are still under investigation, a fascinating theory has emerged. This hypothesis involves stellar activity and mass ejection, presenting an intriguing scenario. Imagine Betelgeuse as a massive volcano quietly ejecting enormous amounts of its material into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had expelled significant amounts of material from its surface into the universe. This event, a colossal mass ejection, involved around 400 billion times the mass typically expelled by similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense dust cloud around the star, temporarily reducing its apparent brightness and making it harder to see. As this dust cloud disperses or is pushed away by the star's radiation pressure, the star's true brightness becomes visible again. This could explain why Betelgeuse returned to its normal luminosity levels after the dimming period. These recent developments suggest a star that isn't done surprising us. Many speculate that Betelgeuse is approaching the end of its life. As we examine the potential for Betelgeuse's supernova, it's essential to consider the broader implications for our cosmic neighborhood. When Betelgeuse reaches the end of its life, the shockwaves from its supernova will ripple through the interstellar medium, creating vast regions of ionized gas and enriching space with heavier elements formed during the star's lifetime. This process plays a crucial role in the ongoing cycle of star formation and planetary creation. The cycle of cosmic renewal. Stars like Betelgeuse are factories for creating elements necessary for life as we know it. During its lifetime, Betelgeuse has fused hydrogen and helium into heavier elements such as carbon, oxygen, and even iron in its core. When the star explodes, these elements will be scattered into space, becoming the building blocks for new stars, planets, and potentially life elsewhere in the universe. This enrichment is a cornerstone of cosmic evolution, ensuring that the universe remains dynamic and ever-changing. Observing a supernova, a rare opportunity. If Betelgeuse's supernova occurs during our lifetimes, it will provide astronomers with an unprecedented opportunity to study the death of a massive star up close. The light curve, spectral data, and shockwave behavior could help refine models of stellar evolution and supernova mechanics. Modern telescopes, both ground-based and space-based, are far more advanced than those used in the past, offering a wealth of data that could revolutionize our understanding of these cataclysmic events. Possible effects on Earth. While Betelgeuse's explosion will be spectacular, it is not expected to pose a significant threat to life on Earth. At a distance of approximately 650 light-years, the star is far enough away that harmful radiation, such as gamma rays, will dissipate before reaching our planet. However, the event could still impact technology, such as satellite communications and GPS systems, due to increased ionization in Earth's upper atmosphere caused by the supernova's radiation. Additionally, the light from the explosion will be so bright that it may be visible during the day and could even cast shadows on Earth at night. This will provide an awe-inspiring natural display, reminding us of the immense forces at play in the universe. What comes after the explosion? After Betelgeuse's supernova, its remnants will likely form a neutron star or, if the core is massive enough, a black hole. Surrounding the remnant will be an expanding nebula of gas and dust, glowing brightly as it is energized by the shockwaves. This nebula will eventually cool and disperse, contributing its materials to the formation of new stars and planetary systems. The Orion constellation, long associated with myths and legends, will gain a new chapter in its story. The fading light of Betelgeuse will be replaced by the brilliant glow of a supernova remnant, a constant reminder of the cycles of creation and destruction that define our universe. A cosmic reminder. Betelgeuse's eventual explosion will be a stark reminder of our place in the cosmos. It will underscore the interconnectedness of all matter, from the tiniest particles on Earth to the most massive stars in the galaxy. The elements forged in stars like Betelgeuse are the very same that make up our bodies, our planet, and everything around us. In witnessing such an event, humanity will not only gain scientific knowledge but also a profound sense of connection to the universe, the role of humanity in observing Betelgeuse. As we await Betelgeuse's supernova, it's worth reflecting on how far humanity has come in understanding the cosmos. From ancient civilizations who gazed at the red star and wove stories around it to modern astronomers using advanced technology, Betelgeuse has been a source of wonder and discovery. The legacy of observations. The star's strange dimming episodes have already taught us much about stellar behavior. By studying phenomena such as mass ejections and dust formation, scientists have gained insights into processes that were once purely theoretical. In particular, the Great Dimming of 2019 to 2020 has reshaped theories about red supergiants, showing that stars like Betelgeuse can undergo dramatic, observable changes even late in their life cycles. Advanced instruments like the Hubble Space Telescope, the James Webb Space Telescope, and radio observatories around the world are poised to monitor every detail when the star eventually goes supernova. These tools will allow researchers to study the explosion in real time, offering answers to questions about supernova mechanics, element creation, and interstellar dynamics. Inspiring future generations. The study of Betelgeuse is not just about unraveling the secrets of a dying star, it's about inspiring curiosity and wonder. When the supernova finally occurs, it will captivate not only scientists but also the public, fostering a sense of awe about the universe. This event may ignite interest in astronomy and space exploration among younger generations, reminding humanity of the importance of exploring beyond our planet. What Betelgeuse teaches us about impermanence. The story of Betelgeuse is also a philosophical one. It reminds us that even the mightiest stars have finite lifespans. Stars are born, live vibrant lives, and ultimately die, their materials recycled into new stars and planets. This process of death and rebirth is a microcosm of the universe itself, a constant cycle of change that has been unfolding for billions of years. Betelgeuse, in its eventual demise, will contribute to the ongoing creation of new cosmic structures. The elements scattered in its supernova will become part of future stars, planets, and perhaps even life forms in distant corners of the galaxy. When will the moment arrive? While predictions for Betelgeuse's supernova range from decades to tens of thousands of years, its eventual explosion is a certainty. The unpredictability of this timeline adds an element of suspense, as humanity continues to monitor this fascinating star. Whether it happens in our lifetimes or in the distant future, Betelgeuse's supernova will serve as a spectacular reminder of the universe's dynamic nature. Looking toward the future. Betelgeuse's story is a testament to the progress of human curiosity and knowledge. By observing the life and death of a single star, we learn not only about the cosmos but also about our own origins. The atoms in our bodies were forged in the hearts of ancient stars, much like Betelgeuse. As such, its supernova is not just an astronomical event, it's a deeply personal one for humanity, connecting us to the vast, evolving universe of which we are an inseparable part.